So we're in test 9 in section 2, and I just want to slowly go over, even some of the easy problems in this section just to make sure everybody's on the same page and following along. So this is literally the page 887, and we're going to look at number 3. So this one says x equals k times k minus 2. Then x plus 1 equals what? So what we have to do here is we have to simply distribute the k. So this is like an easy problem according to, just the difficulty levels in the back of the book. But I mean, since it's got a bunch of variables, I figure it might scare some of you. But you basically just have to distribute the k. So then you get x equals k squared minus 2k. And then to get x plus 1, you're just going to add a 1 to get x plus 1. So that's going to be your answer. That's not too bad. So let's go to number 4. So number 4 is starting to deal with the lines now. And basically, oh wait, I guess you guys can't see it if I tilt it this way. All right. So this one's dealing with lines basically, and I mean, are you all familiar with kind of like dealing with the slope of lines and everything? Maybe, maybe not. Pretty good. I mean, essentially the thing you want to remember for the test, and this is pretty basic, but still, like if you have a line like this, that's like, you can picture like a little like car going from left to right. If it's going down, then that means that this is a negative slope. And if you have one going up like this, then that means if you were going left to right in like a little car, you'd be going up, so that's a positive slope. So I mean, this is pretty basic, but just something really good to remember. So obviously, like E is out in this question, right? Because they're asking us if we double the slope, what happens? And I mean, we're not going to suddenly get a negative slope from a positive slope. But if we still have this y equals ax plus b, is the y-intercept going to change? They're saying, like, the original diagram shows the y-intercept is at 1. So if we double the slope, is the y-intercept going to change?
Yeah.
No. So if we change the slope, nothing happens to, like, the y-intercept. So basically, we just leave that alone and we just, mess with the slope. So essentially, it's just going to make a, like, steeper curve going through 1. Because if we double the slope, we're going to get a steeper curve. So and therefore, the answer is B. So we're on test 9, by the way.
Why wasn't it?
So this is like page 887. Why isn't it C?
Like, they're both on the line.
Right, so both B and C are good candidates, but I mean, if we double the slope, that's going to make this line, like, that's going to make it steeper. So that's going to make it like angled more towards the vertical rather than just kind of more, C is more gradual, sort of. So it's going to be, sorry, it's kind of a bad diagram, but it's going to be growing more slowly, right? It's going to be more towards the horizontal. So that's why C is wrong, because it looks like we're actually taking half of the slope because it's increasing more slowly than the original picture rather than more quickly. So yeah, we're just going for some people who arrived or whatever. We're just going over questions. Nobody did these before lecture. We're just going through them together, and I'm just starting with the easy ones because I want to make sure we're all on the same page and kind of just getting as much as we can. All right, so let's go to number 5. So they're giving us this triangle, and they're telling us that we have x and we have x, and it's a right triangle. So right away, what kind of triangle can we say this is? Yeah, okay, so it's an isosceles right triangle. And what does that mean?
It's a 45, 45.
Yeah, perfect. So that means it's a 45, 45, 90 triangle. So if you look back in like, like where the math section starts, you have like that like table of like, all the different formulas, right? And they give you the formulas for a 45, 45, 90 degree triangle. So this is just going to be x root 2. according to the formulas. So then, if they're telling us the perimeter is 4 plus 2 root 2, then it kind of looks like they're saying, basically x is 2, right? And that should be kind of intuitively obvious. It's not, I don't know, does that seem intuitively obvious? Everyone, like basically, it looks like we're saying 2 plus 2 plus 2 root 2, which would fit perfectly if x were 2. Okay, so then your answer is that x is 2. So that would be A. So these special right triangles are pretty important. And I think, I don't know, sometimes, I forget if it was in this class or people I tutor, but they're like, oh, I don't want to know like the right triangles. I just want to like do it some other way. What's the other way to do it? But they're really, if you don't know the right triangles, it's pretty difficult to do some of the questions. Let's skip number 6 and let's go to number 7. So they're saying this guy has containers of 2 different sizes. And the total capacity of 16 containers of one size is X gallons, and the total capacity of 8 containers of the other size is also X gallons. And so then they're just asking, what is the capacity in gallons of each of the larger containers? So 16 containers, like 16 of, say, container A, go to X gallons. And then 8 containers B go to X gallons. So just from looking at this, which do you think A or B is like a bigger container?
B.
Yeah, exactly. Because like, if there's 16 containers that, make up X gallons, they're each going to be a smaller amount adding to that final sum. So we have 8 containers that make up B. So 8 containers of B that make up X gallons. So to find the capacity of each container, we just take this total capacity and we divide it by 8, the number of containers.
Wait, why by 8?
Just because they say 8 containers in total have the capacity of X gallons, so we want to find how much, water each one can hold individually. So if 8 of them can hold 100 gallons, we're going to say 100 divided by 8 to find which.
So why would you do 16?
Because
Sorry,
these. No, it's just that these are smaller just because there are more of them. Like say X is 100 gallons. So if 16 containers make 100 gallons, or 8 containers of this other type make 100 gallons.
Because they're both X, they have to stay
Yeah,
the same amount of
these are
stuff
smaller and can hold less. Does that make sense? Because
So you need more of them to make 100.
yeah, it's kind of like saying, what if, let's just say for a second this is 16 gallons. So if there's 16 containers that make up 16 gallons in total, then each container is 1 gallon, right?
Mm-hmm.
But if 8 containers make up 16 gallons, then each container is 2 gallons, right? So this one must be bigger. This one, each of these containers must hold more.
Right, so the ones in the bottom just have to be double the
Yeah.
ones on top.
The larger.
Yeah, exactly.
Okay.
So
I like the other one who didn't get that.
No, that's okay. I mean,
Okay.
it's a little bit tricky. I mean, I think this question is actually marked hard, I'm pretty sure, not medium. But I mean, it's just because it's pretty easy conceptually. It's just they're trying to kind of trick you. They have, there's really no reason for them to mention this container at all, right? But
I feel like on these type of problems, I don't know how to set them up.
yeah.
So
Yeah,
you're
Yeah.
how do I set this up?
I mean, if you're confused like that, the best thing to do for this type of problem would be to plug in numbers. Say, oh, as I was saying, the total capacity of all, 8 or 16 is 16 gallons or something, or you could say 100 gallons, and then just type into your calculator what each container can hold, and then just see which one's bigger. So I mean, I would say, your kind of go-to strategy for, tackling these problems where you kind of don't know where, don't know how to set them up, just start picking numbers, just, randomly. Just say, okay, they add up to 100 gallons, and then continue. All right.
What was the answer on that?
So the answer was X over 8,
Got it.
because X is the total over 8 containers. All right, so now rectangle ABCD lies on the XY coordinate plane so that its sides are not parallel to the axes. What is the product of the slopes of all 4 sides of the rectangle ABCD? I love this question. This question's super clever, but it's also, if you don't like see it right away, then it can be pretty difficult. So really, there's only, what I don't like about this question is there's only one way to solve it, and that's like the trick way, the clever way. And if you don't see it, you really have no chance of solving it. Which is, but it is. Before we get into the fill-ins, like the ones where we just fill in the blank and it's not multiple choice, they go from easy to hard. So like 7 and 8 are going to be hard in this section. So
like, how would you know how to set that
okay, so for this one, you kind of have to think about it. I mean, it's a very cool, clever problem, but like it is kind of tricky. So what you have to realize is that these are perpendicular, right? They say it's a rectangle, so all of these are perpendicular. So then, well, we know, and we could plug in numbers for this one, so I'll show you how to do that in a second, but we know
This
basically.
is the kind of problem I read it and I just immediately go to the next one.
Yeah.
No,
well, so maybe let's plug in numbers first. So say the slope of this one is 1/2. Well, this has to be perpendicular, right? So the slope, it has to be -2, right? Because it has to be the negative reciprocal to be perpendicular. And so now this one's also 1/2, and this one's also -2. So
May you just multiply them?
I multiply them, and if I do like 1/2 times -2 over 1, right? These cancel, so I get -1, and then I get the same thing down here with these two. So then I do -1 times -1 equals 1.
Okay, then my only question is, what made you put like 1/2 in there? What if you
It
put like
wouldn't
1/4
matter.
or something?
Yeah, it
You
would.
could do
It doesn't
anything?
matter. You can do anything.
Yeah, as long as
Some of
you,
these things, like, I'm not sure when I should know to put a real number.
Yeah.
Or just make up a number.
I mean,
And then when I have to make up a number, I'm freaking out if I'm making up.
I mean, when they say like, what, for example, they're saying like, what is the product of these sides? Well, so it has to work for everything, right? Like if they're not giving you any numbers, basically you can pick whatever numbers you want. Like if they're not giving you any kind of number in the problem, you can pick whatever number you want because they're not giving you anything, and they're basically, that means the question they're asking should work for all numbers that you pick.
Okay.
So, I mean, if they're not giving you numbers in the problem, just kind of pick whatever numbers you want. If they are giving you a number in the problem, you can still sometimes pick a number, but you have to be more careful.
So, you didn't even need to choose a fraction there?
Yeah.
No, I could
Could you have
choose.
done like 3?
Well, what do you guys want to choose?
3.
Yeah.
All right. So this is 3. So then this has to be -1/3, right? Because it has to be the negative reciprocal.
Okay.
So then this is 3 because these two are the same.
So you're always
right?
going to end up with a fraction.
like, so when you plug in numbers, they kind of have to be correct relative to each other.
Right. So that's kind of what I'm saying. Like you have to, when you plug in numbers, they have to be correct relative to each other. And the more common example of this is like if you have a function and you have like, y equals x squared, and you're saying, okay, I'm going to pick x equals 1 and y equals 2. Well, you can't do that because like if you plug 1 in here, you get 1.
Y depends on X.
Yeah, y depends on x. So you have to just pick like one number. You have to just pick like x or y and then see what the other one is. Or here you can pick 1, but then you have to like follow the rules. So yeah, relative in the problem, usually when you're plugging in numbers, you're picking one number and then you're finding the other numbers based on that number. Sometimes, occasionally, you have to pick like 2 numbers, but usually you pick one number and then you find the other ones based on it. So, I mean, we could say something crazy like, just to show you, to just kind of, iterate this point. Like, I could say like, 524,000 is the slope. So then -1/524,000 is the slope of that. And then we're still going to multiply them all up, and it's still going to be 1 when we multiply all the slopes.
Got it.
So, I mean, so you could be super clever, and you could say, like, oh, I'm going to remember that, like, the slopes are perpendicular, so the product is always -1. You know what I mean? You could do that without plugging numbers, but that's probably not going to happen on the test. So I would just plug in one number and then see what the others are. Okay.
And why do you need negative reciprocal?
That's the definition of like a perpendicular line. Like parallel lines have the same slope, but perpendicular lines have like the negative reciprocal slopes of each other.
Okay.
So yeah, that would be something to kind of memorize with lines and slopes.
So the ABCD didn't really mean anything.
No, yeah, I mean that's just saying we have a rectangle. When they name it like that, they're just naming like the points, but it's irrelevant. It doesn't matter. So I mean,
I feel like they put in so many like unnecessary words and it makes it so
right?
confusing.
No, it's totally true. I mean, they definitely put in more words, and you'll notice. I did want to point this out. You'll notice in question 3, they say if x equals k times k minus 2, then x plus 1 equals what? So like they're checking your reading skills because they want to make sure that you don't just put x. Like it's so tempting to say, okay, x then is k squared minus 2k, and then actually I guess that's not an answer, but usually it is. Like they'll say, they'll have some equation. They'll be like, okay, solve for x. What is x? But really they'll say like, what is x plus 2 or what is 2x or something. So you got to be super careful reading, especially the easy questions. They like to do that just to make it slightly harder. All right, so let's look at 11. So let XYZ triangle be defined as XYZ triangle. So here, X, Y, no, whoops, Y is at the top. X, Y, Z. This is actually an easy question according to the book, which I don't agree with. So essentially when you see something like this, you basically want to just assign, like what they're saying is if you have, they're just defining this. Like this is not a mathematical function that you should know like before taking the test. They're just like arbitrarily defining this and saying like, okay, here we have x, y, z, that's what happens. So, I mean, essentially, let's just do like a really simple example. If we do like x, I don't know, eyeball, y equals like x plus y, if they said like 2 eyeball 1, we would be 2 plus 1. So we essentially just put 2 for x and 1 for y. So that's like all we do. We're just, once we get our new like triangle or new eyeball thing, we just kind of like say, oh, well, x comes first before the eyeball. So 2 is x. And then y is 1. So, I mean, here it doesn't matter because it's just addition. So you can do it either way. But you know what I mean? You're supposed to say 2 is x, 1 is y, and then do that.
So
Okay.
did you just plug those numbers in, like
Yeah.
mix them up again?
Yeah.
Okay.
So I mean, here we've got.
So you could have just put in completely 2 different numbers into one?
Yeah.
Okay.
Yeah, I could put it in any number. So I mean, basically with functions and with these kind of like, shape ones, all we're doing is we're just like, assigning stuff to x, y, and z, and it could be any numbers, and that's what you do. So okay, so we have, so now they're saying 10, 5, 3. So what is 5? Is that x, y, or z?
Z.
Good. What is 3? Good. And what is 10? Good. Okay. Okay, so you guys think it's pretty easy. Okay. So now here, we're going to go to x to the y. So that's going to be 10 to the 3 minus z to the y. So that's going to be 5 to the 3, right? You just do that on your calculator and you're done. So that's all. I mean, it's not hard, right? But it's just kind of like getting oriented with how to set this up.
So you just add those two together?
Yeah, we just do like, 10 cubed minus 5 cubed, and then we just find it. Yep. And I mean, it should be 875 once. Yep. So it's not too bad. All right. So
Can we go over problem 10 possibly, too?
sure.
Just look at it. Just curious about it.
So 10, if the product of 0.3 and a number is equal to 1, what is the number?
Yeah.
Okay. So whenever they have an, and this is pretty common on the SAT too, so
Okay.
it's good that you brought that up. Basically, we want to translate this into an equation. So they're saying the product of 0.3 and a number, so that means like x. So like 0.3 times x equals 1. And I don't know if you've learned kind of like the rules of word problems sort of, but when you have of, that's usually means like you're multiplying them. Yeah, and if you have is, it's usually equals. So we have 0.3 times x equals 1. So then we divide both sides by 0.3, and we type that into our calculator, and then we get it.
Got it.
Oh,
So That's all. All right. Yeah, I mean, if you see any problems that you want to go over as we're going through, let me know. Okay, so let's look at number 12 right now. Okay, so they're saying that the area of PQST is between 10 and 30. So, and they're also telling us that URST is a square. So essentially, this is a plugging in situation again. And we want to find what values of UT might be okay for making the area like between 10 and 30. And the restricting thing here is you might think, well, you can pick kind of almost anything for UT, right? Because like as this gets really, really big, as PT gets really, really big, you can make this this size super small. But that's not true, you know what I mean? Like maybe you could have 5 and like 100. So you have like this base being 105 and then have this base being some really tiny decimal. But we actually can't do that because this is a square. So I mean, if this is 100, then this needs to be 100 too, and that's going to shoot the area way over 30. So we basically need to just try some stuff. So like, let's try 1. So this would be 1. So then we have 5 plus 1, so 6 times 1. The area is 6. That's too little, right? So let's try 2. Okay, so 5
There's like
plus
a lot of possible answers to this question.
There actually aren't too
No?
many. But I mean, they don't want you to put all the possible answers. As soon as
I
you
see,
find
'cause-
one,
'cause
you just put
PU
it
is
in.
So you
stuck
just
at
need to pick
5.
random numbers right now?
Yeah, so we're just picking 1, 2, 3. Yep.
And you're
So-
trying to get up to what?
I'm trying to get
30?
between 10 and 30. Yeah,
Okay.
because that's what the problem says. So in 5 plus 2, so that's 7. 7 times 2 is
Is it
14.
because PU is currently 5, you're kind of limits. the
Right,
numbers
right.
to-
Because the problem is limited. Yeah, because of 2 reasons. One, we have PU is equal to 5 already, and secondly, this is a square. So whatever, like we make this has to be the height too. So if we made this like 50, this would also have to be 50. So that would make the area way too big. So we do 5 plus 2 is 7. 7 times 2 is 14. So that works, right? That's good. If we do 3, that also works because we have 8 times 3, which is 24. And then if we do 4, though, then we're going to get 9 times 4, and that's going to be 36. So that's too big.
So,
So-
3 or 4, 2 or 3.
Yeah, it can only be 2 or 3. That's all. So but you don't, obviously you don't grid in 2 or 3. You grid in 2, or you grid in 3.
Yeah.
Yeah. No, that's, yeah.
2 and 3.
All right, so let's look at number 13.
Wait, so that's all?
Yeah, that's all. Yep. Yeah, it's pretty easy, right? We're just picking numbers and we're just trying. I mean, a lot of these questions, my brother was a math major at Harvard, so he gets really like angry how like, non-rigorous some of like the SAT like solutions are. Like, oh, you just plug in numbers. Well, that's stupid. But I mean, if it gets you the right answer, it gets you the right answer.
Right.
I mean, I like to do it a little more theoretically too. But I mean, I studied engineering at Princeton, so I like to, kind of a little trial and error in the mix. So I mean, you build something, it doesn't work, you build a new version of it. Okay. So I mean, it is good to do it theoretically if you can, but like plugging in numbers is a very quick way to do it. And a lot of the questions, I'd say about 10 or 20% of the questions are designed for you to plug in numbers. Really, like if you did them without plugging numbers, you'd be there for like, half hour. So it's good to plug in numbers. Okay, so let's go to number 13. A company sells boxes of balloons. So I mean, this is an example, and I'll explain to you in a second. This is an example of a question where you don't want to plug in numbers. A company sells boxes of balloons in which the balloons are red, green, or blue. Luan purchased a box of balloons in which 1/3 of them were red. If there were half as many green balloons in the box as red ones, and 18 balloons were blue, how many balloons were in the box? So, I mean, you could start plugging in numbers, but I mean, there's only one solution for this question, and it's not something like a lot of times when you plug in numbers, it's something that like there's a solution that works for any numbers you choose, like the one with the rectangle, or like you can have multiple solutions. I mean, this one it's fixed. We know that we have 1/3 red, and we know we have half as many green. So how many balloons in the box are green? Like what fraction are green?
1/6.
Yep. So 1/6 are green.
Wait, so why 1/6?
Because
it's half as many as
yeah, so it's half as many are red and 1/3 are red. So then
Okay.
1/2 times 1/3. Yep. And then 18 are blue. Well, at this point with the red and green, let's see what percent is left to be blue. So I mean, we have 1/3, which is 2/6 times one. I'm sorry, added to 1/6, so that's 3/6, right? So half, basically half of the balloons are blue, and half are red or green.
You just have to multiply 18 times 2, right?
Right, exactly. We get 36, and that's the answer. So basically, we're saying there are, 1/3 are red, 1/6 are green. So what's remaining, 1 minus 3/6 is 36.
I kind of think instead of doing all that too, if you read the whole thing through and once you get to the 18, I think you can kind of just figure it out in your head almost. Like it's
Yeah,
easy,
no,
like,
you can.
because if you see 1/3 are red and half as many are green, and then you have 18.
Yeah, that's fine. Yeah, I mean, if you can, kind of, I mean, this is, somewhat of an easy question. So I
We
mean, if
do
you
it with
can,
like X's too, right? That's what I did.
yeah,
I did.
what do you mean, like 1/3
Like I did
x? Yeah,
X equals 1/3 X plus 18 plus 1/6 X.
yeah, that's great. Yep.
Alright.
So we could say, I mean, just to kind of say what Robbie is doing, we can say, x is the total number. So we can say 1/3 x, which is the red ones, plus 1/6 x, which is the green ones, plus 18 equals x. So that's,
I like that way.
that might be easier for algebra inclined people. Okay, good. So we can just do that. Okay, so let's look at number 14. The three distinct points P, Q, and R lie on a line L. The four distinct points S, T, U, V lie on a different line that is parallel to line L. What is the total number of different lines that can be drawn so that each contains exactly 2 of the 7 points? So you can do this very fancily by doing like combination permutation type stuff, but I'm going to show you the easy way. And I mean, I think just generally with the permutation combination stuff on this exam, you're either just going to draw it out or you're going to do that whole thing I was showing you with like the blanks where you're like, oh, there are 3 spots. So there are like 3 people to pick for this spot, but then once we pick him, there are only 2 people left, and then there's only 1 person left. You know what I mean? So kind of doing that. I mean, I don't think we have any permutation questions to go over today, but I have, gone over those in the past. So I mean, basically, you could, if you're really comfortable with the permutation and combination like equations, you can use that, but it's better to just draw it out. I'm just going to see if we have different colored markers, but I don't think we do. All right, this is good. Okay. So P can go to S, P can go to T, P can go to U, P can go to V. Then Q can go to S, Q can go to T, Q can go to U, Q can go to V. And then R can go to S, R can go to T, R can, I know this is getting kind of repetitive, R can go to D. So basically, I mean, we're just drawing all the possible lines, and that took like, a minute. And I mean, we basically see that each of these three can go to each of these four, and we see that it's basically 3 times 4. Yeah.
What about like the PQ? Like you don't make those because they're.
No, because I know they're saying.
They're already connected, right?
What?
They're already connected.
Yeah, they're already connected. I'm just seeing if they say. Yeah, that is a little bit.
But how many times in any of these problems in the book do they have them connect them in the same way?
We thought.
Like QS and PQ. Do they ever do that?
Not really. I mean, no, I've seen like SAT 2 Math Level 2 questions sort of do that, but not SAT normal questions. I mean, basically it is because these are already online, but I do agree that's a little bit imprecise. I'm surprised. I mean, I didn't really think of that, but I mean, that is kind of imprecise. Okay, well, they say the total number of different lines, so that would assume not lines on top of each other that are like PQ or PR or the line on top of that, but that I agree that is slightly unclear. But yeah, I mean, basically just they're talking about different lines and the fact that PQ are already on a line and then STUV are already on a line.
So all you have to do is draw lines and count.
Yes. Or you could say, there are 3 points here and 4 here, so I'm just going to multiply 3 and 4. 3 times 4, 12.
I just had a vision of like drawing like 4 lines. 4.
Yeah.
But wait, why does it say like contains exactly 2 of the 7 points?
Because they don't want you to do something funky and like say, oh, here's a line, like and contain like 4 points. I mean, that's not even a line.
What do they mean by that though? Like the 2 of the 7
You mean
points?
that each line can only have 2 points?
Yeah, I mean they're saying.
Wait, the line L lines or the lines drawn to the points?
Wait, what was your question exactly?
Wait, I just don't understand why they say it contains exactly 2 of the 7 points. I don't get what's the deal with
Well, because they're just, a lot of the times it's basically a disclaimer. It's like when you buy M&Ms and they say like, may contain peanuts. Okay, they're saying like, just so you know, we don't mean that you're gonna like, draw a line like I don't know. I mean, even though this isn't a line, they just want to make it clear that it's not like you're gonna draw like, here's like S that you're not gonna say like, oh, here's a line or something crazy.
Okay,
like even though that's not really a line, that's like line segments. They just don't want you to do something crazy. They also say that though because if you're doing, it's kind of a clue if you're doing the combination way of doing it or like the permutation way, that you're like have 7 pick 2. Okay, I'm not really going to go into permutation combination stuff because it's not really that helpful in SAT. But basically, if someone was going to do it that way, exactly 2 points would be a very helpful piece of information. Even though it's implied, it would be helpful and it would be kind of a clue. Okay, but yeah, it's a little redundant. I know, it's kind of when they're saying rectangle ABCD, right? And you're like, well, why do they have ABCD? Well, they're just saying ABCD, like to say that that's the name of the rectangle. But again, it's not useful, and it's just kind of like the disclaimer on like the M&Ms. So don't worry about this too much. I mean, sometimes they say like, oh, they say something like evaluate this function x plus 1 over x, or something for like x does not equal 0. And you might be like, well, what is this? Why is this here? I don't get it. But like, they're just saying that because if you put x in the denominator, if you put 0 there, that's going to make this undefined because you can never have something over 0. So again, this is just like a disclaimer, but it's not that important. Yeah, so don't think too hard about these. I mean, usually the only thing you want to watch out for that's a disclaimer that is important, so a lot of times they say where like p is a positive integer. So that you want to pay attention to because that's going to make your answer wildly different if you know that like x has to be a positive integer. So that's the only disclaimer you want to watch out for. All right, so number 15. This is a really scary exponent question. 2x plus 2x, but it's really clever. I mean, it's really cool. 2x equals 2 to the 7. So any ideas how to approach this one at all? So I mean, exponent questions. Yeah?
I'm just guessing like you could do 7 divided by 4.
Yeah, it's awesome.
7 divided by 4 because there are 4 of these? No, because these are added, so you can't. You could do that if they were Yeah, you could do that if they were multiplied, I think, but you can't do that if they're added.
Oh, like multiplying thing where you add the exponent.
Yeah.
Right?
Do you want to figure out what 2 to the 7 equals first?
That's not too helpful, just because, like, this is in the end, we're going to want to find this exponent. So since we're going to want to find an exponent, like, we want to have the 7 intact.
Can you start adding them?
Well, you can't add them because you don't know, like, what 2 to the x is, because x is a variable, right?
Yeah.
You're trying something, Jimmy, on your calculator. No ideas. All right. So I mean, again, so this is an exponent question. So we're expecting like a simplification trick, right? So I mean, so if were you plugging numbers, you could kind of do that. It's probably not going to get you the answer for a long time. Yeah, you'd probably be sitting there plugging numbers for a while, but you can try that. Yeah. So think about factoring. That's something we always want to think about when we have exponent like questions that are tricky and hard to simplify. Well, can we do anything with factoring or like pulling something out? Maybe no, not really. So there are 4 of these, right? 1, 2, 3, 4. So 4 times 2 to the x equals 2 to the 7th. So that's the big intuitive leap. Yeah.
You just lost me.
Oh, okay. So and we have 1, 2, 3, 4, right? Like it's kind of like saying, x plus x plus x plus x equals 4x. Or, 2 plus 2 plus 2 plus 2 equals 8, which equals 4 times 2. Like, because we have 4 of these, rather than saying 2x plus 2x plus 2x plus 2x, we can say 4 times 2x because there are 4 2x's.
Oh, I see.
Does that make sense? I know it's weird because it's in this like weird exponent form, but if we don't look at this for a second, we just look at like, x plus x plus x plus x, that's definitely 4x, right? Or, 2 plus 2 plus 2 plus 2, well, that's definitely 4 times 2.
I see.
Yeah.
What is the value of x then?
Well, so we have a little more simplification to do, but now it's pretty much like easy from here. So as you were saying, we add the exponents, right? So we have 4 is really 2 to the 2, right?
Yeah.
And now because these are multiplied, we can add the exponents. So we have 2 to the x plus 2 equals 2 to the 7. So that's x equals 5.
Is that like a hard question?
I mean, I think this is one of the hardest questions in this math test. I do, but I think they just rate it as like medium. But I disagree with that. I mean, I think this is one of the hardest questions. What? Yeah, it's extremely intuitive, and there's really, I mean, you could kind of plug in numbers, but you're gonna be kind of sitting there plugging in like 2 to the 1, 2 to the 1, 2 to the 1, 2 to the 1, 2 to the 2, all the way up to 5.
How did you get the x plus 2?
Because you add the exponents. You multiply something. Like when you have like x squared times
Wait, then why
x
don't you have 4 plus 2 2's right there? Like, so you're adding the 2 and the x, right?
Yeah.
The exponents, and then why don't you have like a 4? Because don't you have to multiply or something?
Because 4 turns into 2 squared.
Oh, okay.
So then I add 2 to the x. Yeah. Sorry, what were you saying? No?
But since it's at 4 2x, why can't you just, or why didn't you just go from there and distribute, or just multiply the 4 times 2x?
Because we can't, I mean, what do you think we'd get if we multiply the 4 and the 2x?
3x.
Well, that's not true. I mean, basically, we can't, because this is raised to something power, we can't just multiply the bases.
So when you get to
You have to make it 4 to the power of 1 or whatever, and then 4 times x plus 1 or something?
Yeah, sort of. I mean, that's essentially what I did. You can't add the exponents when the bases are different. So if you have 4 to the 1 times 2 to the x, you can't add those because the bases are different. And you can't, I mean, I'm trying to think of a simpler example. Like if you have 2, if you have 2 to the 3, like 5 times 2 to the 3, that's not going to be like 10 to the 3. That's going to be like 8. Like 2 to the 3 is 8, right? So we're going to have 8 times 5. eventually. So it's not, you can't just multiply the bases like that. So yeah, I mean, exponent rules are pretty important. So, but I mean, you know, again, this problem is pretty intuitive. So I mean, it's okay if you skip something like this on the test, but like, you should just know at least the basics where like, you know, you can't multiply the bases, you can't add exponents with different bases. When you're multiplying, you know, things with exponents with the same base, like 2 to the x, 2 to the y, you get 2 to the x plus y. And if you have 2 to the x to the y power, you get 2 to the xy. So you multiply them in that case. So a lot of people kind of switch these around, but let's make sure you know that. All right, so let's look at number 16. So each of 5 people had a blank card on which they wrote a positive integer. If the average arithmetic mean of these integers is 15, what is the greatest possible integer that could be on one of these cards? So does anyone have a good idea of how to set this up? Maybe no. No. So if they're asking what's the greatest what's the greatest card someone could have, that means all the other ones have like the least amount that they could have, right? You know what I'm saying? Kind of like if we're trying to see the maximum number someone could have, then we have to make all the other ones the least. So we're going to assume that everyone picked a 1 except for the last person. So from there, we're going to set up the average equation. We're going to say 1 plus 1 plus 1 plus 1 plus x over 5 equals 15.
Wait, can you just do 15 times 5?
Yeah, from here, yeah. Or if that was your original inclination, that's fine.
And you can just make all those ones 4s, like a 4.
Yeah, exactly. So that's using the logic of the last question, right?
Right.
1 plus 1 plus 1 plus 1 is actually 4 times the 1. So that was
Okay.
only what I was applying in the exponent question. So 75 equals 4 plus x, and x equals 71.
And can you plug any number in there, or does it have to be 1 that you plug in?
It has to be 1 because we're looking for the least
Okay,
integer.
the least possible.
Everyone else has to have the least integer. And they say it's a positive integer. You might have noticed that. They say
going to the lowest integer you can get.
right, the lowest positive integer, exactly. So I'm just picking 1. I mean, if they said, you know, like it could go to 0, then I'd pick 0. If they said it could be negative, well, then I'm in trouble because I want to plug in, you know, negative infinity, negative infinity. Okay, good.
Real fast, the term integer means like you can't go to decimal, right?
Right, you can't have like 1.5. You need to have like, you know, 1 or 2 or 3. Okay, so, okay, this one's interesting. Alice and Corinne stand back to back. They each take 10 steps in opposite directions away from each other and stop. Alice then, so, okay, so they each take, this is Alice. They each take 10 steps away from each other. Then Alice and Corinne, Alice then turns around. So Corinne stays where she is. And Alice turns around and walks all the way to Corinne and makes it in 17 steps. The length of Alice's steps is how many times the length of one of Corinne's steps. We're assuming that. And again, this is the disclaimer, right? But don't worry about it too much. All of Alice's steps are the same length, and all of Corinne's steps are the same length. So that's what we'd assume anyway. So this is where Alice is here, and then she starts going all the way here.
So wait, so does this mean that for every one of let me see. So does that mean for whenever Corinne takes 10 steps, Alice's equivalent is 7 steps?
Right. So that's good. Great. That's the intuitive leap that you need to make here. Like Alice, when she goes back to her starting point, she's just retraced her steps. So we don't want to think about, Yeah, like she retraced 10 of her steps, but since that was her walking originally, like it's the same length of steps. So like we're essentially just saying, we're reducing the problem to saying she, Alice in this distance was 7 steps and Corinne was 10 steps. So what we can do here is we can say, Alice's steps or what?
So is it just 10 over 7?
Yeah, exactly. Yep. Good. No, that's very good. Saying you can look at this and just say 10 over 7, or if you want to be fancy, you can kind of say, oh, well, 7 steps times like I don't know, each of Alice's steps are like I don't know, like 1 foot equals like 10 times like I don't know, Korean steps are like however many 0.7 feet or whatever. So then we can just divide both sides by 7 and get 10 over 7. But I mean,
Because of that, you decimal that too, right?
yeah,
Divide by 7.
yeah, that's fine, right? You can grid in 10 over 7. You can grid in the decimal of that, whatever you want to do.
Okay.
Yep. Great. Good job. It's good that you got that. Yeah. I mean, basically, no, and like Robbie kind of got the intuitive leap, and you got this. It's good. Okay, great. So that's a pretty challenging question. All right.
Is that marked hard?
I think, yeah, I think it is. Yeah. Yeah, that should be marked hard. All right, so let's look at number 18. And this is the function one. I remember we talked about functions a lot last time. So f of x equals x squared plus 18. And they're saying f of 2m equals 2 times f of m. What is m? So what would be your first inclination, like with this problem?
X equals 2m?
Yeah, like putting in 2m for x, and then that's what you mean, right? So finding f of 2m. So we're going to put in 2m for, because f of x equals x squared plus 18, we're going to say, or if f of 2m is just going to put 2m wherever x is. So that's going to be 2m squared plus 18. And so now, 2f of m, first of all, 2f of m is not the same as f of 2m, right? Like basically, 2f of m is going to be, we're going to plug in m for x, and then we're going to multiply the whole thing by 2. So I'll show you that. So 2f of m is going to be 2 times m squared plus 18. So we're basically, with both of these, we're just taking whatever is supposed to be x, this, or this, and we're just plugging it in everywhere we see x. So once we get this and saying they equal each other, we get 2m squared plus 18 equals, we just set these equal to each other and then we solve. So that's not too bad. You guys know how to solve this, right? Or do you want me to go over solving it? So I mean, it's a little weird because there are m squareds, but there aren't any like m's, so we can just like solve for m squared and then take the square root.
Could you go over it maybe?
Sure. Sure. So from here we've got 4m. Can everybody see this?
Yeah.
Okay, so 4m squared plus 18, right? Because it's 2 squared times m squared, so 4m squared plus 18. And then that equals 2 times m squared plus 18. So that's 2 times m squared plus 36, right? Because we're distributing the 2. So then we're going to subtract 18 from both sides. So we have 4m squared equals 2m squared plus 18. And then we're going to subtract 2m squared from both sides. So we're going to get 2m squared equals 18. So then m squared equals 9. So then m equals 3. plus or minus 3, but I think they ask for the positive value. Yeah. Or I guess they just ask for the value, but that's okay. You can just put 3. So it's not too bad, right? It's just mainly setting up these functions and just being super careful to like make sure you put in m for x and then just multiply the whole thing by 2 versus putting 2m for x and then going about it that way. Yeah, it wasn't too bad. So some of the hardest ones are like I think the exponent one is a lot harder than this, and the one with the steps. So like I don't know what rubric the SAT uses to like classify questions as hard or easy. So let's go now to section 5. And let's look at number 12. So if y is directly proportional to x squared, let's just stop there. What does that mean, y is directly proportional to x squared?
That means like if x squared is changed, then y is also changed.
Okay, I mean that's a good definition of it, but it's a little more specific than that. Does anybody know what it means? I mean, if we say like a is proportional to b, just to kind of like simplify things for a second, what does that mean? Like, no, so it doesn't. Well, a over b that equals what? No, because you're close. You could say a over b equals 5, and then that would be directly proportional because that would be like a equals 5b. But essentially, we're just saying direct proportionality is saying like, a equals 5b or something like that. It means like, or, if x is directly proportional to y, we're going to say y equals, 2x or something like that. So basically a constant times the thing. If we say inversely proportional, that means like y equals like 2 over x. So if we're saying y is directly proportional to x squared, that means y equals some constant times x squared. So and then they're telling us that y equals 1/8 when x equals 1/2. So we can find that constant really easily, and how can we do that? We can find the constant by just plugging in this for x and this for y. So we can say 1/8 equals c times 1/2 squared. Does that make sense? We're just plugging in x equals 1/2 for x and then 1/8 for y. So we get 1/8 equals 1/4 c. So we get c equals 1/2, right? So now we know our equation is y equals 1/2 x squared. And so you might be tempted to just say, okay, we've got 1/2. Well, that's not an answer choice, but if it were, we could just circle and be like, okay, we're done, but we're not done. Because they're asking what is like x when y equals 9/2. And again, when they say the positive value of x, like, again, that's just another disclaimer because you're going to have a positive and negative value because things are squared, but that's okay. So you don't really have to worry about that thing like the positive value. So we're going to plug in 9/2 for y and equals 1/2 x squared. So then if we have 9/2 equals 1/2 x squared, we can just plug in, we can just, actually, let's just eliminate, right? We can eliminate those 2's, right? So we get x squared equals 9. So then x equals plus or minus 3. Okay, so let's look at 14. So h of t is equal to negative 60. And they're telling us that h of t, the function, equals 2t cubed minus 3. So we essentially want to find t, and then be careful. We might be tempted once we find t to pick it, but they're actually asking what is the value of 2 minus 3t. So we have to be careful about that. All right, so we've got this. So h of t is negative 60. So I'm going to plug in negative 60 equals 2 times t cubed minus 3. So now I'm going to proceed to solve. Divide both sides by 2. So I get negative 30 equals t cubed minus 3. If I add 3 to both sides, I get negative 27 equals t cubed. So then I get t equals negative 3, right? So now they're asking me, what, so I mean, I might be, I guess that's not an answer either, but if negative 3 were an answer, we might just pick that. But we actually need to find what is 2 minus 3t. So 2 minus 3t, we're just going to plug in negative 3 for t. So that's going to be 2 plus 9, which is going to give us 11. At this point, we should be pretty comfortable with kind of plugging in, using functions and plugging in values for x and y, and also kind of when we get like those like funky symbol, like weird things to kind of like, figure out which one is like y and x and z and do all of that. I think we have time for one more.
Could we go over 13 real fast?
Yeah.
Yeah, I was
Kind
gonna
of
say the same
freaking
thing.
out. That's probably-
Sure. So we have 4x equals 6u equals 5v equals 7w. And that's all greater than 0. So what I would do for this one is I would choose a number that they all equal, right? Because they're all equal to each other. So I'd say, let's say they all equal 1. So if they all equal 1, that means x equals 1/4, right? And that means u equals 1/6. And that means v equals 1/5. And that means w equals 1/7. So now we know, basically just by looking, we have 1/4, 1/5, 1/6, 1/7. So now, what? Yeah, so now essentially w is the smallest, right? Because it's 1/7, then u, then v, then x. Yeah, I mean, you could figure it out, like, kind of, just in your head, sort of, or theoretically, you kind of say, oh, well, x has got to be the biggest because, you're multiplying it by the smallest thing to get it to the answer. You know what I mean? And you wouldn't have to plug in numbers. I think it's a little easier to see with plugging in numbers, but either is fine. Yes. I guess let's just do one more. Let's look at number 15. If x is divisible by 3 and y is divisible by 5, which of the following is divisible by 15? So x is divisible by 3, y is divisible by 5. So do you think xy would be divisible by 15?
Can you like plug in numbers in this kind of?
Sure. Yeah, sure. Yeah, you can.
So
Sure.
you can make x 9. 'Cause
Uh-huh.
9 divisible by 3.
Yep.
And we can make y like, we can make y like 20 or something.
Sure, that's fine. The only thing is you might want to try, well, you can try everything. It's just that, like, if you choose something too big, like say you chose like obviously you don't want to choose like numbers for x and y. They're basically divisible by the other ones. Like you don't want to choose like, 30 for x, because then x would also be divisible by 5, and that's going to give you like the wrong, and that's going to give you some answers are divisible by 15 when they're not, because x itself is divisible by 15.
So if you do like 6 and 10 or something?
Yeah, so like 9 and 20, 6 and 10, those are all fine. You just want to be careful about choosing, small answers, so you don't like choose, and x that's divisible by 15 already. Like you're kind of assuming that x is divisible by 3, but not by 5, because they're asking which of the following must be divisible by 15. Okay, so so sure, we can do it that way. So I mean 9 times, and you can just plug this into your calculator, 9 times 20, and see if it's divisible by 15. But the other thing to see is that there's a 3 in this 9, right? Being multiplied by 5 in this 20. So that means since 15 is 3 times 5, xy is going to be divisible by 15. And then, but then that's okay. But I mean, I like your way of plugging in numbers because then you can easily just go on the calculator and do it, and see if 9 times 20 is divisible by 15. But if you want to do kind of a clever way, you can be like, oh, there's a 3 in the x, there's a 5 in the y, so x times y, there is going to be 3 times 5 in there, which is going to be a 15. 3x plus 5y. What do you think of that? Then that would be saying like 27, 3 times 9, plus 100. So I mean 127. I mean that's probably not. I mean that's not going to be divisible by 15, but you can check it on your calculator. And then the last one is 5x plus 3y, and that's going to work because y is divisible by 5, and you're multiplying it by 3, so y is going to be divisible by 15, and x is divisible by 3, but then you're multiplying by 5, so that's also this term is going to be divisible by 15, and so is this term. Yep. So then you're going to get something when you add them that's divisible by 15. Yep, okay, that's all.